Alright guys, so here's the old compressor from the Lamborghini LP560 that I just changed out, and in that video I promised I would, when I get time, I would go through the old one, tear it down, and we'll kind of go through what's going on inside this compressor and kind of go through how it works and try to figure out what happened to it, okay? So anyway, I already disassembled it. You see the pieces here, so not much to it. I tried disassembling it from the front here, but there's a little fastener that's on here, and that thing was on there. I couldn't get it off, so I stripped it, which is no big deal. I kind of figured it would strip, but so it's not a big deal. But I can't disassemble this from the front here, and so anyway, you're gonna have to excuse me. Today got allergies really bad. So here in Florida, you know, besides that virus, which is horrible, it's going around. So y'all be safe out there. And then also here in Florida, we have it's pollen season right now, so it's really, really bad outside. I mean, the vehicles are all just completely yellow out there. So we got a mixture of two things going on around here in Florida. So I have to excuse me, my voice is going to be kind of off. But so anyway. So this is the piece where the drive shaft mounts onto the front, right? Okay, so this is mounted on the front of the compressor here, and then I just removed all these fasteners here, pulled this off. Now this piece here, as you can see, is like all rubber around here, okay? And then on the back side, it's rubber too. And at first, when I first seen this, you know, like I was saying before, that this compressor has a built-in fail-safe on it. So if the compressor was to lock up, since it's, you know, direct drive, has a drive shaft going to it, and there's no clutch, that there was a breakaway in here somewhere. And I kind of thought that this would be it, this rubber, but I don't think so. Now that I got it off, and this rubber, I would assume, is kind of tough. It kind of reminds me of like an engine mount or something like that. It's pretty, I mean, it's pretty strong. So maybe this would not be the breakaway. And with me saying that, I think probably this would be the breakaway right here. The reason why I say that is, if you look at this right here, really the only thing that's, if you think about it, you got the power coming from the drive shaft, and it's coming in and it's turning this piece here, which is hooked to this. You have these rubber dampeners in there too, but really the smallest parts that where it's transferring power to the shaft would be through these little, you can see that right there, these little, where it's this little parts right here, these three little areas right here are very narrow. So I would assume that if something locked up, it would probably break right here. Okay, I'm not 100% sure, but just from looking at it, I think this would be the weak point right here, where it would break that off. And then that way the shaft would continue turning, the one coming from the car, and it won't damage anything internally in the engine or anything like that. So yeah. So anyway, I tried to get this nut off here so I can pull this off and and remove the front case, but that was a no-go because it's stripped. Not a big deal. And so anyway, here's what you can see in here. What we have going on the other side is you have these pistons here. Okay. So these are the pistons, and then here's your main shaft coming in. There was some washers here and some thrust bearings. Let me show you right here. They were here. I got them all stacked up here. See the thrust bearing and stuff like that. These were just stacked on there, so just remove those out of the way. And then this right here is a swash plate. Okay, so basically what this does, I can't get this off to show you what it is, but basically the way the swash plate is here, you're going to have another plate that's mounted on this shaft. It's down here, and then what's going to happen is you're going to have a piece that's coming off of there, right, on one side of the plate, and then it's going to have a joint on it, and it's going to have another piece that comes up, and it's going to mount probably to somewhere under this, towards the center section of the swash plate here. Not here on the edge, because see this piston? This piston has a flange that comes down and actually goes under and then rides on the other side of this wash plate. And you can see there's kind of like a bearing right there, and there's the same thing on the other side too. where it rides on there, and this plate just spins around. These pistons stay stationary, and they just move up and down, but this plate spins around like this, okay? So you can see this the surface here is really nice and smooth, okay? So anyway, if you push down on this plate, let me see if I can find out where the, okay, that right there won't go down, so more than likely it's going to be on the opposite side. Let's just move this here. And there it is, okay? So there, the joint's going to be right here, okay? So it's probably hooked up under here, somewhere on the bottom of this plate here. And then this side just goes down because there's nothing on this side over here. And then there's a spring on this shaft right here. It's on the bottom of here. It's putting tension on the bottom of this swash plate. It wants to bring it up pretty much level, okay? I think the swash plate has got a little bit of a tilt to it. It's going to be hard to tell, but a little bit of a tilt, probably around 2 degrees or so. And then basically what that's going to do is, with these pistons staying stationary, if this thing just spins, it's just going to, these pistons are not going to do anything, right? If it spins level. Now, if it's tilted a little bit, one side of it's tilted, so you're going to have a low side over here, and then it's going to go up, and then you're going to have a high side right here. So it's going to be like this. So as it spins, the high side and the low side are revolving around. So if you got, right now it's level, so it's just going to spin. But if this swash plate was to go down, right, you're going to have a low side where I'm pushing at here, and then over here that doesn't go down, it's going to be a high side. So as the low side comes around, it's going to pull this piston down, okay? And it's going to create suction in this cylinder as it goes down because it's sealed. And then as the high side of this plate comes around, it's going to push this up and create pressure, okay? And then push the refrigerant out. So that's how this moves up and down by this swash plate, okay? So in other words, the farther this plate goes down, the more travel this piston goes up and down, which is actually increasing the displacement of the cylinder, okay? So anyway, here's the center section, and this just goes on, you know, these pistons line up in here, and it slides on and goes on a couple pins right here on each side right here and lines up. And like I said, this is the cylinders right here. This is where the pistons ride up and down inside here, okay? And then inside here you have needle bearings, and those actually look pretty good. And then this is your high side port here, okay? And I have it blocked off. And then we're going to go back over here. Also, this is called a front chamber right here. And then this is going to be your rear chamber right here. This on top right here, these are reed valves, okay? There's going to be 2 sets of reed valves. You got the ones on top right here. If you can see this right here. This is almost like a 2-stroke, like, you know, you used to have them in old jet skis with carburetors and stuff. You would have reed valves in them, you know, motorcycles and stuff, 2 strokes. But anyway, this reed valve, it's this plate. Let me pull this off here. See, there's an opening right there. See that opening? And this valve sits right above this reed right here. Sits right above that opening there. See, they line up right here. And so what happens is, if something tries to push this way to go through, it can't, because this is laying flat against that metal, this metal right here. So it's not going to let anything go through. But this will come up and let refrigerant come in, okay? So what's going to happen is, well, I'll show you that in a minute. But there's a reed plate here. This is just a flat metal plate here, okay, which supports these reeds here. And then also on the back side, there's another reed plate here, okay? And then, here, let me get this tool here. I can kind of point this out. If you look really closely under this plate right here, this black plate, you'll see the tip of another reed right there. See it? So this one is going to go this way, up. But that's actually from the pressure. Once the cylinder in here, when the piston's coming up and builds up, it's trying to push the refrigerant out. It's gonna try to come out this way through this reed here. Okay, this is for your high side. And then what happened is, I think they put this plate here to keep this reed from coming too far out. Probably because it's under pressure, a lot of pressure, and it just wants to fly up. But yet when it goes back down for the suction side, it won't let this anything from this high side, once it comes through, it's not going to let it go back, okay? But anyway, I think this plate's here to keep this reed from going too far, because if it goes a little bit farther than it's supposed to, it could cause some fatigue on the metal on the bottom of the reed down here and not let it go back down flat. So I'm pretty sure that's what that's there for. Okay, so that's that. That's this plate here. You got oil everywhere. And then this is your rear chamber right here. Okay. Basically, this rear chamber, it has the low side port right here. This is where your refrigerant comes in. And then what it also has too, it has a high side, like a spring valve right here. Okay. And then it's got that valve there. And basically, it'll let refrigerant under the high side go through this, push the spring in here, this diaphragm, and then come out through this port here, and that will lead to this high side port coming out of the compressor. Okay, so you got that, and let me see. I think that's only moving parts in there is that. So yeah, this is the rear chamber here. So inside, you have another couple chambers inside this rear chamber here. You have your low side chamber here, and then this chamber is going to have your high side in it. Okay, and I'll tell you what. Let me go through. And I'll try to go through and make it just quick on how this compressor works. I'll try to break it down. I'll do the best that I can, okay? So basically what happens is these pistons right here, when this compressor starts turning, when the car's on, it's got, I'm pretty sure this wash plate right here has a slight angle to it. So these pistons are going to be moving very little in the cylinders. They might be going like this, just a barely little bit up and down in these cylinders, not even hardly moving at all, just a little tiny bit, okay? And there's a little bit of pressure built up in this system, okay? Not much, but there's a little bit. Okay, so what's going to happen is it's going to create a suction, okay? When these pistons are going down in these cylinders, it's going to be pulling refrigerant in. So what's going to happen is refrigerant's going to come in through your low side port here. This is open right here. It's going to come in. It's going to fill this chamber up right here, okay? Now this chamber here, this is where your reed plates come in. So let me put this back on here. And if you notice, okay, here's your low side chamber. I'll try to line this up as best I can here. Okay. Now you see these ports. See, they're open to the low side chamber, okay? So the pistons here can suck from each piston has a port that it sucks from. Okay, so it can suck refrigerant in through here, through this, and each one of them has a reed right here. See right here. So in other words, when it sucks, this reed will lift up. It'll let refrigerant in, and then it'll go back down and close this port off on the compression stroke, okay? So the piston goes, down in the cylinder a little bit, creates suction, sucks refrigerant in through this port on the reed valve here, goes into the cylinder. Then what happens is it comes back up, okay? And then it pressurizes the refrigerant and pushes it through this other reed on the other side. Remember, this is closed off now, okay, because it's trying to push on here. It's trying to go out here, but it can't because it's closing off. Then what I'll do is it'll push through here. Let me see if I can get this thing to open up. You can see it actually open up a little bit. So then it'll push it out through this port here, which leads to your high side chamber right here, okay? So each cylinder is going to be pushing refrigerant in this chamber right here all the way around, okay? Then what's going to happen is it's going to work its way over here. You have this like diaphragm, it's on a spring right here, and it pushes down because it's got pressure pushing. It's going to push this out, and it's going to open up a port which leads to this chamber here, which then works its way through here because this port lines up with this port here. It's going to come through here, and it's going to come out here through your high side and hook to your high side line, okay? And then that leads to your condenser up front, okay, of the car. All right. So now what happens is the way it's sitting now, it's the pistons are moving up and down because this is not quite level. It's at I'm assuming it's at a slant, maybe 2 degrees or so. So it's moving these pistons. As the low side of the swash plate comes down, it'll pull the piston down. And as the high side comes up, it'll push it up. Okay, that's what creates your suction and your pressure. Okay, so in order to create more suction and more pressure, you're going to need to adjust this swash plate. So in other words, you need to move it for more displacement, which is more move more refrigerant. It's going to need to go down. Okay, so the lower that swash plate is, okay, the lower it's going to pull that piston down in the cylinder, and the lower it goes down, the more refrigerant it'll suck in through into the cylinder here. It'll suck more in because it's going farther down in the cylinder, and then it'll actually be pushing more out because there's more refrigerant in there, and then you got more flow in this system. Okay, so hopefully that makes sense. But how are you going to control this? Because there's nothing hooking to this, right? All you have is an arm that's under here, which basically holding this side up and only letting one side down, which would create your wobble, which moves your pistons up and down. So the way they control it is with this right here, okay? And this is your DCV, your displacement control valve. At least that's what I'm going to call it. So they might call it something else. So remember, the more displacement, the more farther this piston can get pulled down to the cylinder, the more refrigerant can get pulled in. So this bad boy is right inside here. Oops. Okay, it goes inside here. And then basically what this does, when you have your, when the piston comes up and pushes your refrigerant through this, your reed valve, okay, and it goes into this chamber right here and pressurizes this chamber, okay, you know, you'll have it going out through here and coming out through your high side. But what happened is, if you look, there's a little port inside this chamber, right? And there it is right there, okay? If you follow it down, it leads to inside here, and that's where this displacement control valve is. So basically, the pressurized refrigerant wants to go through here, and it wants to come out here. This is where the outlet is, right? But it can't because this valve is stopping it. There's seals and stuff in there, okay, inside here. So basically, there's a solenoid in here. What happened is solenoid's controlled by your electronic control unit inside your car. So of course, you know, you can turn the AC on and off. You can adjust the temperature there, and then also you have sensors there are a couple sensors throughout the system that report back to the ECU and basically let it know what's going on. Okay, just to be short. So if you want to, let's say right now it's pumping, but it's at very low volume, very low, but it still creates, you know, suction and pressure. So, but what happens is you want the car to be cooler, okay? So in order to do that is you need to move more refrigerant. So in order to move more refrigerant, you have to get more displacement. In order to get more displacement, you have to control this wash plate and get it to go down to get the pistons to move up and down farther. So the way to do that is, oops, this little pin, it just goes right here. This pin, we'll just set it over here. In order to move this wash plate, what happens is each piston right here, okay, when this piston moves up and down, okay, as this compressing Freon and pushing it through that reed valve, it's putting pressure on this piston. There's a force that's against the top of this piston. And in order for this, and these are connected to the wash plate here, right? So what's happening is the force from underneath, specifically that spring under there, okay, is forcing the wash plate up to where these don't really move up and down a lot, okay? Because there's not enough force here. You know, like I said, if it's on this side here, if there's enough force pushing down this piston resistance, it's going to push this plate down, okay? So what happens is, right now you got spring pressure under there, but the pressure inside of here is, how can I say it? It's high. Put it that way right now, because what's happening is, let me go from here. Let me start over again. Okay, so right now the way it sits right here, the car's running. Let's say it's on, but what happened is you want it to get more cooler, okay? So what's happening now is this valve, okay, this displacement control valve, it's opening up this port right here, okay, and is letting high pressure in through here. Get this thing here, letting it in through here. It's coming out here, and then what it's doing is traveling through this plate here. There's like some holes here. Let me see if I can get these lined up. I think it's this hole right here. It'll work its way out. This port right here is lined up with this hole here. It comes through here. It goes through the hole in this case right here, and then works its way into this rear chamber here. This whole thing is sealed because you have this right here sealing it, okay? It's sealed up with this gasket here. So this is a separate chamber here compared to the front chamber from the rear chamber. So what happens, the pressure goes in here, and then what happens is it pressurizes this area here, and then what happens is the pressure under this piston here, this is moving up and down still, very little, but there's a little bit of pressure here, resistance, but the pressure under here is more than what would be up here. So it's going to force this piston up. It's going to want to push it up, and which in turn is going to pull the swash plate up, okay, and push it up with the help of the spring up here. Now, what happens is if you want it to get colder, this valve right here is going to close off this high side port coming out here. It's going to stop letting high pressurized refrigerant come through these ports into this chamber here. So what's going to happen is the pressure is going to drop in this chamber here. So there's going to be less pressure under this piston, under the pistons here. So, and there's going to be more pressure on top. So what's going to happen is going to force the piston down and move the swash plate down, which is going to create more displacement. In other words, the piston is going to be traveling up and down the cylinder more. Every time that low side swash plate swings around, it's going to pull the piston down farther. Every time the high side comes up, it's going to lift it all the way up, okay? And then create your suction and your pressure, okay? So basically that's it. So if you want it to get, if you turn your climate control and you want it to get warmer, then what it's going to do, it's going to send a signal to this valve right here. Then it's going to let high side pressure flow through this hole right here, come out through this port here, go through here, and come into this chamber here, and pressurize it, and help put pressure on the bottom of these pistons, and it's going to be more than what's on top, and it's going to force all these pistons right here on this side here are going to force this swash plate back up to where it creates less displacement, in other words, moving less coolant, and then it's going to cause it to get warmer, okay? And basically that's it. That's how it works. I know it sounds complicated, I know, but basically that's how it works, okay? And then another thing that I'm thinking, this is just my guess, that I would think that if these cars, these engines are really high revving, they're meant for speed, you're banging off the rev limiter, you're just getting on it, and these compressors, you can imagine if you have this compressor, you have the displacement set to where it has maximum displacement and is pushing and pulling as much refrigerant as possible, that these pistons are going to be moving up and down like at lightning speeds, you know what I mean? And it would cause a lot of wear and tear and just be a lot of stress on these parts. What I think is when this car, when you hammer the throttle down, you get on it, I bet you that the computer sends a signal to this displacement control valve, and then what it does, it cuts off the high side here, lets the swash plate come up where it's almost level, to where these pistons are moving minimal up and down, to where there's less work to do here. So it takes less horsepower to spin this over, because anytime you're moving a lot of refrigerant through this system, the displacement's up there, it takes a lot more energy to move all this and push that much refrigerant than with it barely moving up and down and moving less refrigerant. So it takes less power to turn this. And also, I would assume it could turn faster because it's moving less. The pistons are just moving barely like this compared to like this, at 8,000 or whatever RPMs, you know what I'm saying? So I bet you when you hammer it down, that valve closes off the high side, lets this swash plate come up level to where it's less wobbly, it makes it more efficient. And then when you get back off the throttle again, if you have it cold, then it'll cut off this high side pressure go into this chamber here, and then let this swash plate go back down again, and then start pumping the refrigerant around at whatever temperature you got it set at. Okay, so like I said, that's probably just me, because this, I'm just taking a guess, but I'm assuming, that's one way it could control the the wear and tear on these compressors, because actually this compressor looks fantastic inside. There's the pistons, I mean, they look like brand new. I mean, literally, there's no wear on these pistons at all, and the cylinders look good too. They still got, they're just starting to get broke in. It looks like to me. They feel perfect, and the needle bearing's perfect here. There's no debris in the inside any of the chambers or anything. It looks fantastic in here. So, here's what my hypothesis is on this compressor. The failure of it is, I think there's going to be two factors of it. One failure is the noise. If you watch the other video, you can hear the noise in the compressor, and I think the noise was the bearing in the front. And the reason why I say that is because you can definitely, it's notchy, you can feel it. Okay, and another thing is, if you can see it, it's already turning colors where it's getting really, really hot in there. And I'm sure not too much longer it would have seized up, okay? So we had a bearing failure in the front. That's what caused the noise. And then also it stopped cooling. So I'm thinking that this displacement control valve went bad too. So I think we had two failures, okay, on this compressor. So yeah, I think that's what it is. So actually this is good. What I'll do is, I had a friend of mine that owns an AC business. I'll see if he can probably source me out a bearing for the front here, and maybe replace this valve. And then I think we have a good compressor again. Replace these gaskets and stuff in here, and I think it's a good compressor. We can reuse it again for another project. Okay. So yeah, So basically that's it. I mean, it's not that bad once you break it down and think about it. It's pretty simple. It looks kind of complicated, but once you really sit down and look at everything, you can kind of figure it out. So yeah, I think we still have a good compressor. We'll just put it back together and we'll put it in a box. And I say that I'll try to source the parts out, but if I have time, but it'll probably sit in the box for years. So yeah, so there it is. There's the compressor. So yeah, guys, I hope you enjoyed this video. I think we learned something together on this one, right? And so yeah, but anyway, guys, just be safe out there. I know that virus is going around, and I really care about everybody out there. So just be safe, okay? And just use your head sometimes. Don't be going out too much if you don't have to, okay? Because that's the last thing I do is I just want anybody to be sick out there, okay? So just stay well, and we'll talk to you soon. We'll see you on the next project. Okay, guys, have a good day. Bye.